Hi everyone, this is Pramod Kumar Misra. I am a faculty at School of Management Studies, University of Hyderabad. I basically teach operations management and quantitative techniques related subjects. In this particular video, we will be talking about the data management, and within the data management, we will be talking about the quality of the data. All of you are familiar with the quality of the data. We may have the sophisticated software, we may have the right kind of people to do the analysis. If the data is not proper, if the data has a lot of missing values, data has a lot of inaccuracies, inconsistencies, then it will be very, very difficult for someone to do the analysis and draw the inferences. So, in this particular video, we will be talking about how the data can be further refined and data can be further upgraded to a better one. So, the basic definition or the data management is a process by which data are acquired, purified, stored, protected and analyzed to derive the meaningful information about a real world phenomenon. The data so required should be free from errors and deficiencies, that is, should possess the quality dimensions. In this we are talking about the meaningful information. The meaningful information is something, to derive the meaningful information you should have the right data, and the data should be free from the inaccuracies and inconsistencies. So, we basically talk about the dimensions of the data quality. The data quality should have these 6 dimensions. The first one being the accuracy, should be free from the errors. The second one being the completeness, should have the complete information about the data. It should be consistent, should have the reliable information. Timeliness, should be timely and updated wherever needed. Uniqueness, the data should not have the duplicates, should not be repeated multiple times. Validity, should represent the real world scenario so that there will not be much deviation of what the data say versus what we really experience in the world or maybe in the marketplaces. The data purification for quality improvement, in this why it is so essential or what we should basically do for purifying the data is the data what we collect from the market or from the field is like a raw data that may not give the right direction or that may not give the opportunity for directly doing the analysis. We have to have some kind of exercise for bringing the data to the quality level. So, for that what we need to basically do is we have to remove the impurities and anomalies from the data. We should understand the domain and the sector of the study properly. Wherever needed, the domain experts can be engaged. Data cleansing or cleaning or scrubbing, whatever you say, may be expensive and time consuming. So, efforts should be made to control the errors and the deficiencies at the source itself. Software such as Data Wrangler by Stanford and OpenRefine by Google, Trifactor Wrangler, etc. can be used for data cleansing. You can also use the R software for data cleansing. Data quality control at the source, it is very, very important to see to that the data whatever is collected at the source or maybe data whatever is fed into the system should be properly fed so that the users will not have much issues with the analysis. What we basically need to do here is we should have to see to that the data is collected properly from the field. So, for that we should have a good questionnaire design and a kind of a implementation plan which can help reduce the data cleansing related problems. So, what we should basically do in this case is we should segregate the questionnaire into various sections. For an instance like demographics and other things, then we should have the variables and the responses, they should be clearly demonstrated. We should provide the boxes for the responses so that they can be marked or ticked properly by the respondents. The data wherever possible can be pre-coded or the responses can be pre-coded directly in the questionnaire so that while feeding the data in the system, somebody will not have much struggle. Then the next thing is that we can minimize the number of open-ended questions because the open-ended questions basically they are subjective. So, if the more number of open-ended questions are there, then that may create issues while entering the data and in the further analysis. We have to design a pilot test to verify how are the data recorded and their quality. We can train the data entry operators as per the need and get them aware the repercussions of the incomplete and the improper data. Designing the data entering in a particular format should also be done. So data, something that is entered in the system, should have been there in a scientific manner, so that there will not much inaccuracies. Wherever possible, we can go for the sample check of the data quality, so that we can control the invalid data, the misfeeding of the data for the quality improvement. Predefining criteria about the responses to improve the consistency level can also be done. Quality improvement techniques, we can basically talk about a few things. The first one being the data cleansing, or you can say data cleaning or data scrubbing. Then second one being the data coding. Third one being the data restructuring and the filtering wherever essential, data transformation. Then finally we can have a reliability check of the data. Data cleansing. In the data cleansing, we can talk about a few things. In the data cleansing, we have to define clearly the variables with the appropriate length. We can enter the data, or you can enter the consistent data in the data editor or the spreadsheet. Related information can go to the variable view or can be mentioned separately. Proper formatting and the labeling of the data, special characters, codes, spaces, etc. should be avoided while defining the variables and feeding them. Duplicate variables, they are basically stated in the columns, and the duplicate cases, basically the cases are the rows, should be deleted, or wherever possible we can merge them. Empty columns, empty columns are basically the variables we can delete, and we can delete also the cases or the empty cases or the rows that are completely blank, so they may create a lot of issues while analysis. Identifying and treating the missing values with a prefixed criteria. There may be missing values. The missing values may be due to the non-response of the respondent, or it could be due to the feeding of the data that is something inappropriate, which may not add value to the analysis. We can declare them as the missing value. And for the missing value treatment, we have certain concepts or maybe certain treatment for that. We will be talking little later in this particular video. As far as possible, no cell should be kept incomplete unless not responded by the respondent. As you all know that outliers, they are basically the unusual figures that may be there in a particular variable. So you can treat the outliers with some treatment, and the best one could be you can find the quartiles. As you know that Q1 is the quartile 1 or the first quartile, Q3 is the third quartile, and Q2 is the median. So if you can take Q3 minus Q1, that becomes our interquartile range. And if you see the entire bell-shaped curve, we can have Q1 minus 1.5 times of interquartile range, and Q3 plus 1.5 times interquartile range. That is basically the range. If a particular data or maybe the value is not falling in this particular range, then we can probably remove it so that our data will be more consistent. Miscoded or invalid entries should be either deleted or rectified. Second one being the data coding, and in the data coding, we can have the data entries or the responses. They may be either string or maybe you can say string or the qualitative variables or the numerical variables, can be numerically coded as per the convenience and should be labeled immediately. For instance, if we have if we collect the data in the number or as a continuous variable, and the continuous variable can be further recoded as a discrete variable. So the thing here is, when we are discretizing the particular variable, then we can have the categories, and those categories can be further labeled. But one thing we have to keep in mind, that this particular categories should be properly representing the data what we have derived from the earlier case. Missing or the invalid data or the values or the cells can be numerically coded as 99, 99, 999, etc. And this 99 or 999 or maybe 9999, something like that, should be different from the responses, and such values should be declared as the missing values. So what happens here is, if you do not declare this as the missing values, then they may be taken in the analysis. The software may be taken by default in the analysis. So the analysis or the outcome of the analysis will be really misleading unless you declare this as the missing values. It is to be noted that coding is for facilitating the analysis and not for changing the characteristic of the variable. So when we change the continuous variable to the categorical variable, that is for improving the reliability or the consistency of the data set, but it is not for changing the characteristic of the variable itself. So this one we have to keep in mind. Responses should be duly dealt with while doing the analysis. Data coding may improve the internal consistency among the variables in a data set. Then the next item in this is data restructuring and the filtering. So data restructuring and the filtering, what basically you can do is, you can merge two different files and we can have a single file. We can merge the variables, or you can say we can restructure the variables in the form of transposing the variables. That means row can be columns or columns can be rows, how we do the things in the matrix. Sorting cases or the variables, we can put the cases either in the ascending order or the descending order, or with respect to the alphabet or the numericals. If you are sorting the variables, then probably we can take the help of the type or the value of the variable, etc. That helps also in this splitting the file. Selecting cases, we can select the cases. If we have large number of cases and we want to select a few cases, we can go for the random selection. We can also select on the basis of the specified range or with some kind of if condition. Splitting cases, we can we can take the subset of the data with some criteria that may help us in the analysis. For an instance, if we have the data, the market data of the consumer behavior, and we have both male and female, and we have educated, uneducated, high income group, low income group. If we want to have a kind of analysis of the individual group, and that will help us to see how the things are varying over the aggregate analysis, and how that is or how the outcomes are in a particular group, that may help us in that. Then the next item is the data transformation. In the data transformation, we can shift the values with some criteria. That means either you can take the data to a later stage, or you can take the data to the backward stage. In the financial analysis, we may use this particular analysis, and we can take the data to some lag. That means the data will be shifted to a few points, so that we can do that. That is a kind of a lag what we do in the financial analysis. Also, we can take the backward. That means we have to leave the few data points right from the beginning, and we have to take the later data, so that that can be coming in the new data sheet. Then recoding into the same variable, recoding into the different variable. These are the very important things in the data transformation. The first thing is that recoding into the same variable. What we basically do is, we collect the data, for an instance, as a continuous variable, and we recode it. Then what happens in the process, the recoded data is the categorical data, and the categorical data may not again give us the continuous data. So it is very important that we should have a master file, who is probably we shouldn't change anything, and whatever changes we do, we should do in a different file. Then the second one is the recoding into different variable. What happens here is, we have the continuous data, as well as we can recode the same data to by creating another variable, and that variable will be with the categorical data, and both the information will be available in the data sheet, so that we can see both continuous as well as the categorical variable. Computing a variable from the set of other variables. When we compute a particular variable, and that is the result of two other existing variable, that also gives sometimes a kind of a new variable that generates, and that may be useful sometimes. For an instance, if we say, suppose x and y, there are two variables, and they are impacting another variable called z, and if we put z is equal to say x plus y in simple terms, that means z is the new variable that we have created, and that new variable is nothing but the impact of the addition of x and y. Ranking of the cases. The ranking of the cases can be done for a particular variable with or without any criteria. We can keep some criteria for ranking the cases. We may not keep the criteria for ranking the cases. Simply the ranking can be done on the basis of either highest to the lowest or maybe lowest to the highest, depending on the requirement. Replacing the missing values. This is very important, and as you all know that we may have the data, and the data may have a lot of missing places, and those missing places or the missing values may not really give us the right kind of direction for doing the analysis. So we can treat them before we go for the analysis. So what basically you can do in this missing value treatment is basically either you can replace them with mean, or maybe you can replace them with a median, or we can simply regress the items, and we can check what could be the value for that particular variable and for that particular case. You should remember that if you want to have a treatment for the missing values, and then you should go for all this kind of treatment, that is replacing with the mean, median, mode, or maybe with regressed values, or maybe something like to be replaced by a random number, or depending on the kind of distribution in the data sheet. But one thing, if you want to have a kind of, if you want to have the replacement for the missing values, then one thing has to be seen that should not be coded as 99, because 99 once we declare, that means the data is missing, and we should not really change it later. But if you want the treatment for the missing value, that means right from the beginning we can have some kind of criteria what should be really replacing the missing value. Then we can also create the dummy variables. The data labels can be set that different variables. We can take the values of ones or zeros. You might have seen the dummy variables that basically take the values of ones and zeros, and those ones and zeros, for an instance, if you say the gender, and in the gender if you say male is equal to 0 and female is equal to 1, and we can create two different variables, one for the male and one for the female. So whoever is a male, it will be 1 0, whoever will be a female, it will be whoever will be male, it will be 0 1, who will be a female, it will be 1 0. Similarly, other values also can be created, but they will have the values at 1 and ones and zeros. Data reduction. And in the data reduction, we can have several things here. One is the data elimination. We can simply eliminate the data depending on large number of missing values in the same. We can remove the data, or we can remove a particular variable where we can find that there is a high degree of coefficient of variation. Before we calculate the coefficient of variation, we can also find the mean of the particular variable, and we can find the standard deviation of the particular variable. If you can take the standard deviation by mean, that becomes the coefficient of variation. If it is very high, probably that particular variable will be really not be very useful in analysis. We can probably keep it aside. Data aggregation. Data labels can be valued or maybe calculated with the help of mean, median, etc. That means two or more labels can be treated with the mean of the entire variable, or maybe with the median of the entire variable. Data normalization. This data normalization is another important aspect in the data cleansing or in the data reduction. So what basically happens here in the data normalization is we have the variable, and that particular variable may be very inconsistent from the viewpoint of the reliability. What can be done in that is we can replace or we can standardize the particular variable with the help of the normalization. And how can the normalization be done is like the standard normal variate you may be familiar with, and that particular standard normal variate is nothing but your the value of the particular case minus the mean of that particular variable what you have calculated, and standard deviation is nothing but the sigma. That sigma also can be calculated from the particular variable. So for a particular case, if you can take x minus mean by sigma, so that will be the value for that particular case, and that case whatever value we generate through the process of standardization, that may be varying between -3 to +3, because -3 to +3 almost 99.7% of the data is covered. And when the data is normal, that may impact the reliability, and reliability means the data will be more consistent, and we can go for the further analysis. Another way of standardizing the data is nothing but the feature scaling, and this is slightly different from the data normalization. What we do here is we have to basically see the case value, and the case value we can take in that particular variable. We can have the mean of that particular case, and we can have the maximum as well, and what we can take from there is the value what the respondent has given. We have to subtract the minimum in that particular category or minimum of the values in that particular variable, and we have to divide the difference between the difference between the maximum and the minimum of that particular variable. So here x is nothing but the level of a particular case, and maximum and minimum, as I said, they are respectively maximum and minimum values of that particular variable. So the feature scaling and the data normalization are very important aspects in the quantitative data analysis. Another way of doing the things is we have discussed a little early, that is the discretization, and in the discretization, if the data is basically a continuous variable, and in the continuous variable we want the data to be categorized, then probably what we can do is we can categorize on the basis of certain concept, or maybe on the basis of certain methods, and these are nothing but we can have decoding, we can take the minimum and we can take the maximum, and you can divide by, if you want 4 different levels, we can code with 4 different categories, or you can take as in a case of normal distribution, -1 standard deviation to +1 standard deviation, -2 standard deviation to +2 standard deviation, -3 standard deviation to +3 standard deviation. We can also categorize in that way, and in some of the softwares the automatic recode is also available. For an instance, in SPSS by IBM, you also have that automatic recode available, so the data will be recorded into 4 different categories. So one thing has to be remembered here: once you are discretizing the data or discretizing a particular variable and you are recoding into the same variable, then getting the earlier data will be difficult, and so we have to keep the master data that is somewhere else, so that we can see what was really responded by the respondents. So another sophisticated method that we can employ here is nothing but your principal component analysis, and in the principal component analysis, in a particular scale we may have several independent variables, and in the several independent variables they may have a lot of similarities, and those similarities can be taken into consideration, and another value can be created probably with the help of maybe a linear equation, and we can find which particular variable is really impacting that particular factor, and that factor has several other variables. So this is a sophisticated technique that also helps us in finding the better result, and the data what we basically collect can give us the better reliability. Then one more thing in the quantitative data analysis, we can check the reliability, and as you know that we use the 5-point rating scale, 5-point Likert rating scale, or 7-point Likert scale. So in the scale we measure the things on the basis of 1 being the strongly disagree to 7 being the strongly agree, and we have to accordingly recode, or you can codify all these things in the entry itself, so that somebody doesn't have to enter this strongly disagree to strongly agree and so on, so that data will be more consistent right from the beginning. In case it is entered literally, that is strongly disagree, strongly agree, and neutral and things like that, then probably we can codify it later by giving the appropriate number. For instance, if we say strongly disagree is equal to 1 and strongly agree is equal to say 5 in a 5-point rating scale and 3 being the neutral, then we have we can probably improve the consistency of the variables in a particular scale. So in this we have one thing that is very important statistics, that is nothing but Cronbach alpha, and this Cronbach alpha is a very important statistic here, and that can be used to see whether the data is consistent, that is the data is reliable for the further analysis. So what we can do basically here is we can calculate this particular Cronbach alpha, and in some of the softwares it can be automatically calculated, and if you want to numerically calculate or maybe manually you can calculate, alpha is equal to k by k minus 1 into 1 minus summation variance of x by variance of x by variance of y. So what can be done here is basically you can have the particular x is a function of y, where you have x is a function of y, where let us say x is equal to y1 plus y2 plus y3 and so on. Then you can find the variance of the y, and you can add all of them and divide with the variance of x. So that will be a particular variance of the overall variables in the particular scale, and that is nothing but your inconsistencies, and or you can say the unreliability in the picture. So if you can subtract that from 1, then that and multiply with k by k minus 1, that becomes your reliability. There is another way of dealing with this, that is k into c bar divided by b bar plus k minus 1 into c bar. So what is the c bar is basically the covariance between the item pairs. If you have the variables, and you can take the covariance among all of them, and you can find the mean of all the covariances. Similarly, you can find the variance of a particular variable, and if you can take this particular statistic, that is k into c bar divided by b bar plus k minus 1 into c bar, that will also be giving us the value of Cronbach alpha. And in the social science research, basically the Cronbach alpha value of 0.7 or above is generally accepted, and this particular value we have to see, and we have to improve, because it is very important that unless the Cronbach alpha in a quantitative analysis is more than 0.7, then it will not give us the right kind of inference, and that may not be truly representing the real world phenomenon. So in this particular case, you can refer to the IBM SPSS software, and you can exercise all this kind of discussion what we have talked. And you can also see those who are familiar with R programming, then in the R programming also the similar kind of things can be done. But here in R programming we may have to write the code, but in SPSS it is menu based, things are already available, you can use for your analysis. Thank you very much.